Hi STEM students! Welcome to our class in Pre-Calculus. Distance learning might be a different and challenging experience to all of you students, but don't worry, I am here, your teacher Cheryl, and I will be with you in exploring the topics and concepts in your subject, Pre-Calculus. But before we start our lesson, let us ask first the divine intervention of our God for this video lesson. Our most precious Heavenly Loving Father, we praise and glorify you this moment. Thank you for the gift of life, and thank you for giving us a chance to experience this different way of learning. Grant us wisdom that we may use to understand our lessons and help us overcome the challenges that we face during distance learning. Please keep us safe from the spread of the virus during this pandemic. This we ask in the name of your Son, Jesus Christ. Amen. In mathematics, there is no such thing as too big nor too small, because together we can learn it all. Are you excited to learn? Our objective for today's topic is, at the end of this video lesson, you will be able to define the degrees and radians, and also you are able to convert degrees to radians and vice versa. Maybe some of you may wonder, why is it that we need to convert degrees to radians? You're already used in using degrees as a measure of an angle. But this time, let's try to check it with a similar situation. Just take a look at this fraction 1/3 and the decimal 0.333, which is a repeating and non-terminating decimal. Of course, 1/3 and 0.33333 is equivalent to each other. However, 0.33 is usually rounded off as 0.33, which is on the hundredths place. Now, let's try to multiply 1/3 and 0.33 into 3. 1/3 times 3, the answer will be 1. And 0.33 multiplied by 3, the answer is 0.99. See the difference? There is a little problem with 0.33. It don't get the exact value. But with 1/3, it got the exact value of 1. It is still the same with the radian measure and the degree measure. Degree measure can be compared to the decimal form, while the fraction can be compared to the radian measure. Since we have already used degrees as a measure during our geometry classes, it is important to use the radian measure in trigonometry classes. And that is why it is important for us to learn converting of degrees to radians. But before we proceed to the conversion, let us first define the degree and radian. Degree is defined as the unit of measure used to represent the measurement of an angle. In practical geometry, we use degree as a unit of measure, and it is represented by this symbol. A protractor is also used as a tool to measure the degree measure of an angle. However, the radian is referred as the measurement of what an angle has to open, such that the length of the section of the circle's circumference it captures is equal to the length of the radius. This definition is very important, especially when we are deriving the formula in converting degrees to radians. Let's proceed now to our first activity. We have here our guide questions. First question is, what is the measurement of one revolution in degrees? Do you know that? The answer is 360 degrees. That is equivalent to one revolution. Let's have our next question. What is the formula for finding the circumference of the circle? This is your lesson when you were on grade 7. Can you still remember that? Well, the formula for circumference is 2 pi r. The idea for circumference will be used later on in order to find the radian measure of the whole circle. Let's proceed to question number 3. Going back to the definition of the radian, stating that it is the measurement of what an angle has to open, such that the length of the section of the circle's circumference it captures is equal to the length of the radius. What do you think would be the radian measure of a circle if you divide all the measure of the radius, all the measure of the radii from the circumference? Take note that the formula for circumference is 2 pi r. If you divide it with r, what is now the answer? See, r is cancelled and we get 2 pi radians. Fourth question. Since 2 pi radian is equal to 1 revolution and 360 degrees is also the measure of the circle in 1 revolution, what do you think? Are they equal to each other? Remember the transitive property? Equals, being equal to equals, are also equal. That is the statement of Euclid, which is one of his first 5 postulates. So it means that 2 pi radian is equal to 360 degrees since they are both equal to 1 revolution. Now, since the measure of 2 pi radians is 360 degrees, how much is the measure of 1 pi radian? If your answer is 180 degrees, well done! You are good in mental math. But for those who don't get it, since 2 pi radians is equal to 360, you should divide it by 2. Then, you'll get 1 pi radians, which is equal to 360 divided by 2. And the answer is 180 degrees. So now, 1 pi radians is equal to 180 degrees. That idea will be used now in converting degrees to radians. Next question. Since pi is equal to 180 degrees, do you know how to convert 75 degrees into pi radians? How are you going to do that? Okay, please prepare your pens and modules as we try to check the examples that are given in your module. Okay, so prepare it now. You can pause this video, and after preparing that, let's proceed to our next activity. Are you ready? Let's check the example 1. Express the following degree measure to radian measure. Number 1 given is 75 degrees. And so, if we want to convert 75 degrees into radian measure, what is the solution in your module? Have you observed? 75 is multiplied to pi over 180. Then, they look for the factors of 75 and 180. Common factors are cancelled in order to reduce the value into the lowest form. And then, you're going to put there pi radians after the reduced fractional form. Try to check number 2. That's 240 degrees. If converted to radian, did it follow the same method? Try to observe and check your modules. How about number 3? What is the process used on number 3? Is it the same with number 1 and number 2? Try to check the solution on number 4. If it's the same all throughout from example 1 to example 4, it means that that is the only solution in converting degrees to radians, and that is to multiply the given degree into pi over 180 degrees. And if you are going to reduce that into lowest term, the answers would be on pi radian measure. Now, try to check the example number 2. Example number 2 is about converting radian measures into degree measure. Given number 1 is pi over 8 radians. Can you see the solution and how did it convert it into degrees? It is multiplied with 180 degrees over pi. Try to check if the same solution is applied on example number 2, number 3, and number 4. Again, you can pause this video while you are checking the examples, and after that, you can move on if you have already checked the examples. Are the solutions the same from number 1 to number 4? Then, we can say that the only solution for that in converting radians to degree measure is to multiply the radian measure by 180 degrees over pi. Now let's have a summary of all the things that we have learned this time. First is, we know about degree. A degree measure is commonly used in geometry, while a radian measure is used in dealing with unit circles in trigonometry. A degree is defined as a unit of measure used to represent the measurement of an angle, while the radian is a measurement of what an angle has to open, such that the length of the section of the circle's circumference it captures is equal to the length of the radius. And then, by converting degree to radian, we simply multiply the degree with pi over 180 degrees, and then reduce it into lowest term and put the radian measure. Then, in converting radians to degrees, all you have to do is multiply the radian measure into 180 over pi. And that would be the degree measure if you convert it into decimal form. Now, it's your turn to answer the exercises which is written on your module. Try to answer exercise 1, numbers 1 to 3, and exercise 2, numbers 1 to 3. You can pause this video and wait until you finish answering. Are you done answering? Let us now discuss the answers on exercise 1. For exercise 1, the first given is 30 degrees. We should convert it into radian measure. So what are we going to do? 30 degrees multiplied by pi over 180. Then if we cancel 30 and 80, that would be 1 over 6. Therefore, the radian measure would be pi over 6 radians. continue with number 2. Number 2 is given as 55 degrees. 55 degrees multiplied to pi over 180, that would be 55 pi over 180 radians. But we should reduce 55 over 180 into lowest term. What is the common multiple or the common divisor of 55 and 180? That is 5. So 55 divided by 5 is 11, and 180 divided by 5 is 36. So that would be 11 over 36 pi radians. And for number 3, we get 108 degrees. 108 degrees, when converted into radian measure, that could be again multiplied with pi over 180. And then, if we should divide it into 3, then 108 divided by 3 would be 36. And 180 divided by 3 would be 60. So we get 36 over 60, which still can be reduced into lowest term. 36 divided by 12 is 3, and 60 divided by 12 is 5. So the answer would be 3/5 pi radians. That's very easy. If you don't get it, you can again review and rewatch this video. Let's continue to answer our exercise 2. For exercise 2, number 1 is to convert 1 over pi over 24 radians into degree measure. So we should multiply it with 180 over pi. Pi is cancelled. Then we should divide 180 by 24. What do you think would be the answer? 180 divided by 24 is? Okay. So, if you got it correctly, it means that you are very good in cancellation and division. Or if not, you can always use the calculator in order to solve larger or complex values of numbers. Let us now answer question number 2. That is pi over 15 radians. If you are going to convert that into degrees, you have to multiply it with 180 over pi. Again, pi is cancelled, then 180 divided by 15 would be 12. So that's it. It's 12 degrees. And the last one, we have 5 pi over 18 radians. So that's 5 pi over 18 radians. Multiply it with 180 over pi. If we cancel 18 and 180, we'll get 10 from 180 and 1 from 18. So that would result to 5 times 10, which is 50 degrees. That would be the answer for number 3. Did you get it all correctly? Well, if you don't get it correctly, you can always rewatch this video before you proceed to the evaluation part. Okay, for your evaluation, for exercise 1, numbers 4 and 5, and exercise 2, numbers 4 and 5. You could always submit that via Messenger. You can take a photo of your answer and send it to me through Messenger, or you can send that to me during the submission of modules. And for your assignment, you should write your reflection. List the things that you have learned in the video and determine the things that you want to learn more. Thank you for being with me in this class, and I hope that this has helped a lot in your learning journey. God bless everyone.